Guys, we're gonna try a couple of these. These are easy. So this is gonna be a right triangle. And did I have this labeled as C here probably? What did I have an A here maybe?
You have a large A there.
Okay. And a large B here.
Yep.
Okay, guys, where I jump into the numbers, we like to label the angles with capital letters, angles A, B, and C. And then throughout the trig, all the courses for trig, they like to label with small letters the sides opposite. So in other words, capital A represents angle A inside that triangle. The side opposite it will be labeled as a lowercase a. Just to match up like that. Capital C is my right angle, 90 degrees. Opposite it is C, lowercase c, for the length of the side. Capital B represents angle B at the top, its measure, angle B is up there. Lowercase b represents the side here. So, okay, so the lowercase letters are being used to represent the length of those sides opposite the capital letters. And we do this in all the trig courses. Now, Shane, did I give you some numbers to be placed on that triangle?
Yes, you had small b, so the side, as 5.
5 here.
Yep. And large B is 20 degrees.
And 20 degrees here.
Mm-hmm.
And guys, what she's asked me to do is solve that triangle. In other words, find the missing parts. So this is going to be the easiest part of the entire course. To find the missing parts, guys, I see angle A is missing, capital A. I'll find that. Lowercase a, side A is missing. I'll find that with help from Mr. Park. And side C is missing. We'll have an approximate sign here probably. So approximate answers for those two. And guys, I think that's all that's missing. So they're saying find the missing parts of that triangle. Now to me, and I think for you, I think angle A is going to be the fastest to find. What should all three angles of a triangle sum up to? 180. 180. So we have 90, right triangle. 90 plus 20, that's what, 110? So that's going to quickly force this to be 70 degrees. And you're done. Now though, lowercase a, side A, the length of this side here, which is BC, and the length of side C, is going to require what I was doing at the end on the board there before the break. So guys, does anyone see a way to set something up to help find the length of side A? This right here. Now I've labeled it with an A.
Tangent.
Now if you try tangent, okay, tangent of what angle? Now by the way, I'm going to put 70 here. We've already found that. You want to use tan, sine, cosine? What should we use? It's up to you. And tell me which angle you want to work with. You want to do sine 20? You want to do cosine 70? Which one you want to do? Or does it make a difference?
We could do the same thing.
Any ideas?
Same thing.
Sine of 20? Okay. Now if I do sine 20, here we go. Now let's go. I know I erased it. It came out to be what? Opposite over hypotenuse. The opposite side for 20, he chose 20. The opposite side has a length of 5. That true? The hypotenuse is C, which I am looking for. Did I express that correctly, guys? Is that the side opposite the angle he wants to work with?
Mm-hmm.
So it's opposite over, and of course the hypotenuse is C. Now, if I find C here, Mr. Park, we'll do a quick cross multiplication. Quick. Try to find C here. Divide by sine of 20. Here we go. Mr. Park, be very careful. Ignacio says approximate 5 divided by sine of 20 for me. Let's see what that is.
It's like 14.6.
14.6? That one's done. He says it's approximately 14.6. Now I'm left with side A. Any,
A squared plus B squared.
look, A A squared plus B squared is equal to what, C squared?
Square.
Pythagorean theorem? Now, here, definitely can use it. Mr. Park, I'm gonna get ready for you again. That's Pythagorean theorem for a right triangle. Shane, was that you who said C squared is equal to A squared plus B squared? Okay, now C was 14.6. I know these are awkward numbers. I would not give you awkward numbers on the final exam. I couldn't, because you had no calculators. But 14.6 squared equals A squared, and A is missing, plus B squared. B was given to me as a 5. Mr. Park, guy, help me out. What's 14.6 squared first? Got to crunch these numbers out. 14.6 times 14.6.
21, 3, so 213.
213.
Yeah, point 16.
15?
16.16.
16.
Yeah.
Okay, it's equal to this. A squared plus 25. I can move the 25 there. Move that 25 over.
Okay.
Oh boy, oh boy. 213.16 subtract 25. Mr. Park, help me.
188.16.
188 point how much?
16.
16
Yeah.
is equal to A squared, and then A is gonna be the square root of that mess. And don't you mess me up here, Mr. Park. What's that approximate answer?
It's 13.71.
13.71?
Yeah.
And that's side A out of the way. Is that true? Now, if there's no mistakes there, we're done. I think we have all the parts of the triangle finished, do we? Is that true, guys?
Yes.
The right triangles? Okay. Now you say, I know some of my students were saying, Professor, I don't have a calculator for the final exam. If you give me one of these, what are you gonna do? I've got to give you inside here, not 70, maybe 60. And not 20, but maybe 45. Then you could do this with 60 and 45. You couldn't do it with a 20 and a 70 unless you had a calculator to work with. Shane, I think we finished that one up.
Yeah.
For goodness sakes, did I just have one more?
We have one more triangle, yeah.
Now, more than likely, let me see if I did this. Did I have this to maybe sit sort of opposite from that first one? Did I have the vertical side over here this time?
Yep.
And it looks something like this. And more than likely, that right angle, Shane, was C again?
Yeah, that was large C.
Where's large A located?
Up top.
Up here. And B, then I know how to label my lowercase letters. This is lowercase c, lowercase a, lowercase b, opposite.
And you gave us lowercase a equals 2,
That's 2.
and then lowercase b equals 8.
How much?
8.
8?
Mm-hmm.
Okay, guys, and you're supposed to find the missing parts. Now, missing, let me label what's missing first. Missing is angle A, capital A is missing. Capital B, angle B is missing. And lowercase c is missing. Now, which one would you guys like to find first?
Lowercase c.
I would, lowercase c. How you gonna find it? Pythagorean theorem, c squared is equal to a squared plus b squared, absolutely, Pythagorean theorem on that right triangle. In this case, that's c squared is equal to, I gave you a, that was a 2. B was an 8. And you ended up with what, 4 plus 64, guys, that's 68, I think. Do a square root on 68 to find out what c is. Not perfect square root, but I could simplify it. 4 times 17, I think it is. What is that, 2 radical 17? Guys, I think it is, someone check me. Is it 2 radical 17? Besides C. Is it? Okay. That's done. I'll leave it like that. Now how about the angles? Angle A, angle B, the capital letters. That's where I need some big time help.
Sine inverse?
Don't get close. You're probably thinking correctly. A little bit more more detail. How you gonna find either A or B?
Sine theta equals.
Okay, sine, which one you want, A or B?
A.
Okay, you want sine A, angle A. I know by definition that's opposite over hypotenuse from tonight. Well, the opposite, if you're using this angle, is what? 2 over the hypotenuse, which is that strange number there. I agree with him, opposite over hypotenuse. To clean that up somewhat, yes, this is 1. Rationalize, Mr. Park. Yeah, I need you to help here. To find out what A is though, that's sine A. I heard Ignacio say, Professor, looks like you may have to use an inverse to finish this up. You think so? For guys to find out what A is, I'm gonna ask him to apply the inverse sign on this crazy number, and do not let me make a mistake. Mr. Park, can you do that for me? Inverse sign on that radical 17 over 17.
It's 14.03.
How much?
14.03.
14.03?
Yeah.
And that's in degrees.
Uh-huh.
Okay, so we got this approximate answer, 14.03 degrees. Now see what's helped also there. Guys, the only thing left is, this is 2 radical 17, I'm gonna put that in. Left is angle B. Bella,
Why did we use the inverse? I don't understand that.
beautiful, right here. If sine A is equal to radical 17 over 17, but they're asking to find A. Now I've got to do an inverse on that to find out what angle A is. I'm trying to think of another way to explain it to you here. Okay, let me ask you this. Can you tell me from the previous worksheet, I think it was, Bella, can you translate this and tell a class what does this mean? The way it's written, just the way it's written. What does this mean? I don't want to put you on the spot there, but what does A equals inverse sine of radical 17 over 17? I know it looks strange. What does it mean? Or, look at this. If I saw this, hang on. Hang on. What does that mean? You see that? I know it looks a little strange, but what does it really mean? It says sine of 5 over 6, which is 1/2.
I see, okay.
We said the same thing down here. Except they have different numbers than what you guys are accustomed to. Okay. Bella, that help?
Yeah.
Okay. Now, if I'm confident, Ignacio, with what you helped me out with, I can find the remaining angle, B, if I'm confident with my answers, by taking what? This 90 plus the one you gave me, add them up and subtract from what? 180. And that would give me what this is. So guys, we can do it like this. Angle B, let's take 180, because all 3 angles should sum up to 180, and subtract from it, now look at this, 90 plus 14.03, help me out. Is that 104.03? And that difference is, for an answer, Mr. Parker, can you help me out? What's 180 subtract 104.03?
I think it's 75.97.
75 point something?
97.
Oh, that sounds good. 97. Good, was that you? 75.97 degrees. Are we okay? And you have all the sides, everything solved for it. And you could have taken different approaches here. Okay, guys, I know all this is closing down. Now, Shane.
Yep.
We're about to finish this up here. Part 2. What on earth did I do on that worksheet for part 2?
Law of sines and law of cosines.
Are you kidding? Hang on. Did I have another triangle somewhere around there to say solve? Is there another triangle drawn on that handout to say solve?
I mean, way at the bottom
Okay, at the bottom there, there was one?
Find the area of the shaded region.
Oh, yeah, find the area. Okay, guys, first off, before I do that, let me do this. I just thought about it. And Shane's gonna help me out here. It's this. Here it is. Hang on. Yes. So guys, I'm gonna give you a triangle, looks like this.
Okay, do you mean a sketched triangle?
Oh, did I give one there?
Well, no, or a theoretical triangle. You have a solved a given triangle, but it's not drawn.
It's not sketched for you.
Yeah.
Okay. I'm gonna label this guy as this, A, B, C, capital letters. And lowercase letters, opposite, represent the length of the sides. Now, the way that triangle's drawn, it's not a right triangle. They call these oblique triangles. This is not a right triangle. So Ignacio, what we were working with over here, opposite of a hypotenuse, there is no hypotenuse. So I can't use these definitions you saw right before the break, and then what I applied on the last problem there. This, by the way, is an acute. All the angles inside are less than 90 acute. You could also have an obtuse triangle, but I think your textbook uses the word oblique if they're not a right triangle. Did I have oblique on that handout somewhere? A non-right triangle? Did I have that?
Yeah.
Okay, guys, and you tell me, did I have some measures though for some angles or sides?
Yeah,
Okay, what did I give you?
you gave us large A equals 40
40,
degrees. B, large B is 60 degrees. And A, the side, is 4.
4. Okay, guys, get ready. You've got to solve this triangle. In other words, find the missing parts. And it's not a right triangle. Daniel, missing is angle C. Missing is side B. And missing is side C. Any ideas?
Split it in half.
Now, that's what many students will say, professor, drop a perpendicular. For goodness sakes, drop a perpendicular for help here. Nasi, I'll do that for you. Now you're going to help me out. If you do drop a perpendicular on this oblique triangle, yes, you have formed a couple of right triangles. Now, what are you going to do with it?
On the sides of each one, and then like the base.
Okay, now, by the way, you have right triangles now, so you can use opposite of hypotenuse, adjacent of hypotenuse, all that business from high school. Do I have enough there to do that? Like if I ask you to find sine 40. Sine should be opposite of hypotenuse, where the opposite is this blue, altitude or height, over the hypotenuse, which is B. This is unknown, this is unknown. That's not going to help. If I ask you to express maybe sine of 60, in that right triangle, opposite is that blue, and hypotenuse is 4. That might help you find what that blue is. Would that help you guys? So suppose I go to the right triangle on the right here, and ask you to express on the side here sine of 60 degrees. And let's go ahead and call this H for height, altitude. Opposite of a hypotenuse for 60 would be, opposite is H, and hypotenuse is 4, yes or no? So this becomes 4 sine 60 equals H. I know what sine 60 is. You know what sine 60 is. What is sine 60? I just said everybody knows it. Radical through 2. I'll leave Mr. Park for right now. Clean that up. you get 2 radical 3 is the height. They didn't ask me to find the height. They asked me to find this, which we have not found yet. Now what?
You can add 40 plus 60 and subtract it from 1.
Love it. 40 plus 60 is what, 100? And all 3 angles should sum up to what, 180? So that quickly, Bella, thank you, that quickly tells me this is 80. That's out of the way. Now how about my 2 sides, side B, side C? Any way to find those? Yes?
If the angle C is 80 and it's been split in 2, it's gonna be.
Whoa, 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 whoa. So the 80 at the top, as a student, I would probably think it's split up into 40 and 40. I think it's what I'm hearing. Am I guaranteed that, guys?
No.
Nope. I wish it were. Oh, it would make my work much easier. Split that 80 at the top there up into a 40 and a 40. No, it may be a 50 and a 30. So I'm not guaranteed it's going to be a bisector. Ignacio, you got me started.
We should do tangent 60.
Whoa, I'm trying, I'm desperate now, before I show you another approach here. And then stop and do something in chapter 11 here shortly. Tan of what?
60?
Okay, if you do tan, by this new definition for a right triangle, and I do have right triangles, it's opposite over adjacent. So 60, the opposite would be 2 radical 3. And the adjacent would be what?
C over 2? Or just,
1/2 of.
yeah, 1/2 C?
1/2.
Are you looking at this right triangle here?
Mm-hmm.
I'm doing tangent.
Yeah.
Okay, so tan of 60, I'm with you so far. Tan of 60 is opposite, which is 2 radical 3, over adjacent, the side next to. Well, the side next to that right triangle is this side.
Yeah.
Do I know what its length is?
No, but we're gonna find it out, right?
Oh, we are. From C to B.
From the, yeah.
I better label it like that. Ah, Mr. Mathematician. He says, I don't know what that is, Professor, but maybe we can find it, right? Do a quick cross multiplication. Wow. And we'll move into chapter 11 here shortly, guys, for something different. And come back to this on Wednesday before you take that test. Ignacio, what are you going to do now?
Divide by,
Divide by what, tan 60?
yeah.
Jeez. This guy is something else. Tan 60. These cross out. So from C to B, Mr. Park, I need your help. What is this 2 radical 3? Get out of your way there. Divide by tan 60 that Ignacio gave me.
Just 2.
Yeah, it's just 2, right?
Right here.
Just 2.
It's just 2.
Okay, well, oh, by the way, could we figure this out without, are you telling me it's merely what?
Yeah, 2.
2. Could we have done that without the calculator? Could we have done tan 60 if we had time to do it, but, okay, we could have, but he says 2. Ignacio, that's not one of the parts I want here. I want side C, which goes all the way across. Side C represents all this. Now what?
You could find AC.
Oh my goodness. Now how are you gonna find A to C? Or what, tan maybe of what? 40 or?
AC equal to 2 radical 3 cotangent.
Okay, could I also use tan again though, if I wish? What, tan of 40 was it? And that's opposite over adjacent. If you're using this here, guys, opposite is 2 radical 3. What a workout. I did not plan to do it this way, but you guys led me into it. 2 radical 3 over what, AC? Is that true? Okay, Mr. Park, I may need your help on this one. You're going to end up with AC tan 40, wow, equals this. Divide by tan 40, yeah, we'll definitely need your help here. Oh my goodness, tan 40. Please cross out. Mr. Park, can you tell me what, if I have no mistake, what is that close to?
No, but it's 4.12.
4.2?
1, 2. Yeah, 1, 2.
Oh, Lord. Now, if all that's correct, do I have enough now to answer side C? 6 point, what, 1, 2? Ignacio, there's nothing wrong, I love that reasoning. Now, the other side missing is B. You guys let me into it, and what you're saying is 100% valid. This wasn't the way I was going to approach it myself. But it's valid. A little bit longer. I'm gonna go get B.
C squared minus A
C
squared.
squared is equal to what? A squared plus B squared? And if I do that, and then we'll close this down. Now you guys can step back and look at it. Side C is 6.12 squared. A was given to me as 4 plus B squared. Mr. Park, what's 6.12 squared first?
It's 37.45.
37.45.
Uh-huh.
Subtract 16. How would I do that?
21.45.
21.45, and then do a square root on that,
Okay.
and that should be B. And what is that? I think,
4.6.
how much? 4.63?
6. 3. Yeah.
That's this right here. And my goodness, you guys did it, not the way I was going to do it, but you did it. 4.63. Now is the triangle finished? I want to get into that chapter 11. I'm not quite there yet. I'm trying to get this chapter 7 closed down. Shane, is there something else on there? I know you said law of signs. Okay, now hang on, guys. Law of signs, I'm gonna do one little item, and then we'll give you another handout. So you can see this is a different topic in chapter 11. I wish there's no triangles there. The law of signs, Ignacio, you got me started on this, and I appreciate you. Now, suppose I do this. I think a good way to do this. Let me try another, what they call oblique, non-right triangle. I'm gonna have mine look like this. Just on the side here. And I think a good way to approach this, angle A, call it, angle B, angle C, of course, these. Okay, I think a good way to do this. Am I ready for this? I think I am. I'd like to express the area of that triangle. I don't have any numbers in there right now. Express the area of that triangle. And I know, and a middle school kid knows, if they're asked to find the area of a triangle, the formula that comes to mind, guys, see if I'm right, is the area equal to 1/2 base times height. Yes or no? So if a standard area formula is 1/2 base times height, that means I need a height on this triangle. If I want to express the areas, I need to draw the height in. Let's see if I'm ready for this. There's my height. Now, Alexander, if I ask you to express the area, and keep in mind that lowercase c represents the length of this entire side of this triangle. Can you tell the class what it would look like on my triangle if I apply this middle school area formula? Would my area look like on this particular triangle? It says 1/2 of what? What's acting as my base? C, the way my triangle is labeled C. That's my base. And the height, of course, I labeled it as H, so I'll keep that the way it is. So right now, you say, Professor, it's 1/2 CH, or HC. That true, guys? Now, I'm gonna call it step 1. That's the area of that triangle. Step 2, since I dropped that perpendicular, I have 2 right triangles involved. Guys, the right triangle on the left. Suppose I ask you to express the sine of angle A using this right triangle that's on the left in the sketch, where sine is opposite over hypotenuse. What would that look like here? H over B. Would you guys agree? Is that the opposite side of the triangle? And here, this represents the hypotenuse, the side opposite the right angle, B. Better expressed as B sine A is equal to H. No problem. Now suppose you go to the other side, there's another right triangle. Since I dropped that perpendicular, it's over here. And guys, in this one, I'd like to express sine of angle B in that red triangle. Right here. And sine is still opposite over hypotenuse. What would the opposite of the hypotenuse look like in the red triangle? H over A. Better expressed as just a quick cross multiplication. You got this. Now, on the side here we go. My area formula is this, 1/2 C times H. Could I write this as 1/2 C? Could I substitute that H with this, B sine A? Could that be a substitute for that if I wish? So I'm gonna go back to my standard area formula, number 1, step 1, and replace that H right there with step 2. I see a B sine A. Or a substitute for H. Another student may say, wait, Professor, could you not have gone back to step 1, 1/2 C, and in place of H, you have another substitute you could have used. Is this also H?
Yeah.
So you could have placed there for H, a student may say do that. A sine B. Yes or no?
Yes.
Woo! Now, let me translate what this means. Ignacio, class. This is take 1/2 the product of B and C. That's these two sides here. Take 1/2 the product of these two sides times the sine of what angle? The angle caught between, angle A. Another student may say, well, Professor, no, I prefer this version. What do you prefer? I'll take 1/2 of A times C. I want these two sides, Professor. Go for it. A times C, but sine of what angle? B, which is caught between. I see one I'm leaving out. I see another version a student could ask me to write that I don't have on the board right now as 1/2 of, now can someone give me the last version that I don't have up here yet? Based on what we're doing here. the other two sides may be what, A and B? B, A and B. If I chose A and B, which I don't have up here right now, that would be sine of what angle? C. Is C the one in between? So sine 1/2 of AB sine C. Yes or no? Woo! You guys agree with that? A little logic here before we close this down? Okay. Now, I'd like to clean that up a little bit. And when I say cleaned up, multiply everything by 2, clear the 2's out. So I'll take it down to here. I'm gonna call this guy's BC. I'm gonna turn around a bit, sine A. I'm clearing the 2's out. Here, AC, sine B. And here, AB, sine C. Everyone with me? 2's have been cleared out? Let's multiply everything by 2. Yes? No? Okay. Now my last step, and when I do this, I think some of my students will recognize what's going to fall out. This is where I'm going to stop on the trig for tonight, and then come back to it on Wednesday. I'm going to now do this to it. Divide these results by this expression. All the way through. And then cleaned up. I chose A, B, C to divide everything by. If I divide by A, B, C, the B's and the C's cancel out in my first term. Leaving what? Sine angle A over what? A. Here, my second expression, the A's cancel, the C's cancel, leaving sine B over lowercase b. How cute. Last one, the A's cancel, B's cancel. Leaves me sine what? C over C. Does anyone recognize this conclusion? Let's give it a name. It's on your handout. That's called the law of sines. What is it used for? I could go back and solve what Ignacio helped me out so much with. I could have solved, Ignacio, I think I could have solved this triangle much faster with the help of the law of sines. So this is called, guys, this is called the law of sines, which can be used especially when they ask you to solve an oblique, non-right triangle. Now, that's good, good, good. I'm going to do it by law of sines and we'll close this down. Ignacio, Mr. Park, class, you've helped me out. We finally, let me see what we did here. We finally got this one finished up, didn't we? Now, let me go back to the original. Let me go back to what was originally given to me and see if I have enough to apply this new law here, law of sines, and not go through all this that we went through earlier, but yet get the answer. I'm going back to the original business here. Guys, we did not know what that was, I don't think. Shane, I think you gave this to me. I'm going to do this. So I think we were looking for those items, which we found. And the definitely is 80 degrees. Now guys, suppose I use law of sines. Can anyone match up in this triangle without going through all that we went through earlier and tell me what would law of sines look like applied to this particular triangle, if possible?
Sine of 40 over 4.
Thank you, sine 40 over 4 equals
Sine of 60.
sine of 60
Over B.
over b. That's exactly what they're matched up for you down there. Do a quick cross multiplication. I'll do it fairly quickly here. B sine 40. Cross multiplication. 4 sine 60. Divide through by sine 40. Patient to get this done. Mr. Park,
Mhm.
okay, I'm gonna need your help here. These canceled. Mr. Park, would you approximate this right here, 4 times sine of 60, divide by sine 40, and tell me what B is close to by this method?
It's like 5.39.
Well, what did we get last time?
Four.
We got 4 point something, didn't we? I erased it.
Oh, really?
No, that's, 4 times sine 60, it's too close to the end of class. Divide by sine 40.
I got 5.39.
Oh,
Sorry.
no, it may be us. We should have gotten the same answer. Shouldn't we? Now see how I went through everything you told me to get? Yeah, Mr. Park. You said it's 5 point something this time.
Yeah, it's 5.39.
Guys, we did set the law of sides correctly, didn't we? Shane said that for me based on that down there, which I thought would be a shortcut and not go through all that business we went through earlier. Guys, side B's got to be the same answer. Did we mess up law of signs? I'm looking at quicker to close this down. I don't see that. You sure?
Yeah.
Just place those numbers you gave me. Maybe it's one of the numbers that we used down here that we got that was wrong and threw us off a little bit. I don't have the calculator with me. Okay, as I get that handout to them,
Mhm.
I recheck it.
Okay.
Because it should be 4 point something. It was 4 point something, I think. Right? Unless it should have been 5 point something earlier.
Oh.
Check it out for me.
Okay.
Okay, I'll leave it at that. Guys, I'm picking up this on, Wednesday? Because I have maybe an hour before that test takes place on Wednesday. And then this will finish up chapter 7 for the most part. Now, got a little time here. Gotta do it. Now, I know we're tired, but, gotta do it. Oh, I hope we have enough copies. Okay. Alexander, do me a favor. He's gonna be busy checking on that problem. Pass these out. So. Mr. Park, in other words, just redo that problem. It could be us, but
Okay.
just redo it. Okay, guys, got about 12 minutes here. Mr. Park, do we need that? I'm gonna erase this. You know what you're
Yeah,
looking
you
for?
can
You want to
erase it.
redo everything, right?
Yeah, I'll redo
And
it.
see if you can get everything to agree. Okay, Shane?
Yeah.
Whew, you're a word at doing all this. On that handout. I see right here. Sec 11.1, something entirely different. This is closing down the course. It says there's a definition. And they're saying now turn your attention to not triangles, something called sequence. And I'll have just enough time to introduce this. Okay, Shane, read that definition. I'm not gonna rewrite it.
A sequence is a function whose domain is the set of positive integers and whose range is a subset of the real numbers R.
Okay, so a sequence is a function whose domain is a set of positive integers. Guys, here it goes. Hang on. So I jump all the way into it. Seems like I brought something in myself to look at. With this. I did. Okay, here we go, guys. We'll give you a sequence. Now, by the way, from the definition, and then we'll ask her to repeat that definition for me. Most students, probably all students, if I ask you to give me what you think a sequence is, an example. Many students say, Professor, a sequence of numbers, maybe this. I want this to be infinite. Let's make it go forever. That's what I, as a student, I'm sure you too. If you're saying sequence, in my mind, Professor, that's a sequence. Elements, items, separated by a comma. Is that true, guys? So what they want is for you now to take that sequence, I'll give you an example there, and rename it as a function. Or name a function that would give you those terms. Does anyone have, and let's use maybe f of x, I'm going to use f of x for right now. Does anyone have in mind a function that might give me 1, 3, 5, 7, 9, 11, those terms in that sequence? I see a hand going up. And by the way, when you finally give the function to me, Shane's already told me, you can replace that x only with positive integers. And the smallest positive integer is 1. So if I replace 1 in your function when you give it to me, I had better get 1. When you give me what you think it is, and I replace x by 2, you get 3. When I replace x by 3, you get 5. Now I saw some hands going up. Yes?
2n minus 1.
Love it. Okay, he says n, I'm going to use an x here for right now. He says, Professor, no problem, 2x minus 1. So by Shane's definition, if I replace x by first 1 in here, in his formula, I get 1. Replace x by 2, I get 4 minus 1, I get 3. X by 3, I get 5. That's what they're looking for, a function that would satisfy those terms. Thank you. He's given it to me correctly. Now though, your textbook and all textbooks are asking now, sure, this is a function. I heard the word function mentioned, but they like different notation for a sequence. They like to call this not f of x, guys, just notation. A subscript n is equal to 2n subtract 1. They like that notation a subscript n rather than f of x. Billy, if I accept that, that's the reason they do this, they're saying now suppose you're asked as a student to find a subscript 6, which indicates you're looking for the 6th term in that sequence. Well, my sequence is so easy, you can actually count up and find the 6. But if I use the formula, it's 2 times 6 minus 1 is 11. So guys, I went up to 7. So if you go up to the 6th term, I might think the 6th term should be 11. Ignacio, if they ask you to find what is the value of the 75th term, that's why they like that notation, go to your formula, 2 times 75 in this case, subtract 1, I think it's 149, is it? 150 subtract 1?
Yeah.
So you're guaranteed, if you carry this on out, it's infinite, to the 75th term, its value will be 149. Make sense, guys? They will not ask you to do this. Now in this class, they're not going to ask you to find this. That. A subscript 0. Shane's already told me, no, Professor, they're saying this has to start with a 1. I think it's what, positive integers, they said? So you're not going to see this. You always start out with a 1, then 2, then 3. You'll see no fractions. So guys, that's why they like to use that a subscript n just to find a particular term in that sequence. Now, on the side here, and to close me down tonight, so I can jump into this next time I see you guys, I had, find it, this. Do you guys appreciate all this hard work your instructor's doing for you?
Yes.
Can you imagine coming in here and just saying, just read on your own and do a test? that to you. Okay, here we go. Next one looks like this. We'll just try a few here before we close down. Sequence, 1/2, 1/4. I brought in 1/16, and I made this infinite. I'd like to have a function, I'm gonna use their notation, a formula that might give me those terms. And when you think you know what it is, if I replace n by 1, always start with 1, I had better get 1/2. Replace n by 2, and whatever you think the formula is, I should get 1/4. By 3, 1/16. Anyone have an idea? Or is there one? Love this. Mr. Hahn.
1/2 to the power of 2 to the power of n.
Wait, 2 squared?
2 squared, yeah.
Hang on. Raised to n? Are you saying that?
N minus 1.
N plus 1?
Minus 1. Minus.
Whoa, out here?
Yes. And I mean, how can I say that?
Which I love though, he's thinking.
Yeah, it's working.
Okay, let me stop right there, just for the sake of my students. If I should replace in your formula the way it looks right now, n by 2, I should get 1/4.
Yes.
Let's see if I do. A subscript 2, 1/, I think you're calling this just 4, aren't you?
Oh, no, I mean, there's
No,
one
you
more
different.
step.
2 raised to what?
2 raised to 2
Oh,
raised to
gee.
raised to n.
Well,
Can I write?
what you gave me there? No, that's 4 raised. Whoa.
There's different.
Well, is that 1/4 though? I did it quickly.
There's
Is that 1/4? With a crazy formula, did I replace it correctly, guys? I replaced n by 2 in this crazy formula. Look at this, n by 2, I didn't mess up, I hope. This is really 4 here, right? Raised to the first.
there is not 4.
Oh, you don't want that to be 4, but
There's
it worked on the second term,
no.
right? But he doesn't want it.
Doesn't work on
Does it work on the first term?
That's why I want to rewrite that.
I know exactly what you're thinking.
No.
2 raised that, yeah, I know. First term would look like this. Replace n by 1. Which gives me, what, 1/2 raised to, guys, is it 0 here? Is it?
Are you saying,
2 to the power of 2n minus 1?
Yeah,
That's-
to the
yeah.
power of
2n minus
2
1.
2
to
n
the
minus
power
1?
of minus 1.
Whoa.
2 to the power of 2.
Oh, are you saying this?
Like that? Is that?
No.
Okay.
Can I write?
Right for me, yeah. But I wasn't thinking about this.
Sorry. I tried to
Okay.
say.
Oh, let me see if I- oh.
Three stage.
Let's go. A subscript n is equal to 1/, Mr. Hahn, you said 2,
Yes.
raised to the 2,
Yes.
raised to the n plus 1.
Yes. No, minus 1.
Nice one.
Yep.
Are we allowed to do that?
We are allowed, if it works. If it works, this guy's out there, he says, I'm gonna try it, then we're gonna close down here. First term, A subscript 1, by his formula would be, well, I've gotta make sure I have this written down. Is this it right here?
Yep.
Okay, 1/, 2 raised to the 2 raised to the 1 subtract 1. Gee, 1 over 2 raised to the 2 raised to the what? 0. And that is 2 raised to the 0, which is what? 1. Mr. Hahn,
Yes. Oh, no.
No, it's
The
2 to the
first
power
two
of
to the
1.
zero.
Yeah.
oh, down here.
Yeah.
So you finally ended up with this.
Yeah.
Yeah.
Yep. it looks working.
And it looks like it's working.
Yeah.
Guys, did I put everything in there correctly?
Yeah.
Based on this, he's like that, I tried to write it like that, and it looks like it's working, okay? Whoa. Now, Alexander, to close down. Suppose I go back and change this, just for the sake of doing this. He's giving me this, which looks like it's working, just trying not to commend you. Now, suppose I give you this.
Yeah, should be 8.
Now, might that make it a little easier to come up with a formula if that had been 1/8 and not 1/16? What might the formula now, it's gonna be a 1 definitely over something. Over what? 2 raised to the what?
10.
If I replace n by 1, do I get 1/2? Replace n by 2, 1 over what? 2 squared 4. N by 3, 2 cubed is 8, 1 over 8. Much more sense. That's what I had planned, and Mr. Hahn, with his brilliance out there, I was hoping that, see, darn it, I was playing the trick on my class. I put a 1/16 and Alexandra, I wanted a 1 over 8, but I said, no, we'll do it and see what they come up with. And he came up with 1. I thought Norm would come up with a formula. Geez, he came up with 1. I want this one now. Everyone sees this one.
Yeah.
Okay. Here goes. Last one. Trying to think about indeed that anything else. Let's see. I don't know. I'll end class tonight with that one. To close down class. Now, does anyone see a pattern there? Or does anyone recognize this sequence? It was given a name back in the day whenever we saw something about sequences here. Does anyone see a pattern here before we close down?
Is that the golden ratio?
All right, tell me again.
The golden ratio?
Oh, we're not going, getting close.
Fibonacci.
Fibonacci, name for the mathematician. Mr. Fibonacci sequence. But I need to come up with, before we close down, which we're going to close down right in a second here. Just first, I'm not going to give you a formula tonight. Does anyone see a pattern at least?
I'll see what, add 0,
The previous.
add 1, add 2, add 3.
Billy, let me ask you this. If I take these two terms and add them up, do I get the third term? If I take these two terms and add them up, do I get the next term? If I add these two up, 2 plus 3, do I get 5 the next term? And 3 plus 5 gives me what, 8? 8 plus 5 gives me 13. Is that consistent all the way through? If I do it like that. And exactly, but now to come up with a formula to show that will be to show you on Wednesday. For you guys. Had a good class tonight, we had a lot done here though. Ah, me. Mr. Park has, Eugene, you guys probably sent the answers out to the review, and then I'll send out the graphs.